Yeah, so first of all, I wasn't expecting that many people here as the last presentation, so thank you and congratulations, all of you, on making it this far. And yeah, we can begin. So my name is Eligijus Bujokas, as I was very pleasantly introduced, and I work in a company called ID Vilnius, which is shocking, but is based in Lithuania's capital city of Vilnius. And before I begin my formal presentation, I just want to seize the opportunity of standing on this stage and say a couple of things. So first of all, to all the Swedes in the room, I want to congratulate you on joining NATO. So welcome to the family. And the second thing, well, most of my adult life, I wanted to thank somebody from Sweden for IKEA, because without IKEA, the flat back in the flat back in Vilnius would be like 50% more empty. So yeah, thanks for that. And now we can go back to the formal part of the presentation. So as I said, I work in a company called ID Vilnius, and our goal is a very noble one. We want to better the lives of not only Vilnius citizens, but its guests as well. So how do we do that? Well, we do it by focusing on these three pillars right here. And the central pillar is, of course, the people of Vilnius. And we track various statistics and visualize data about demographics, about healthcare, about the air quality in Vilnius, where people can, well, it's open sourced and people can view those dashboards. Of course, a big part of the city is the infrastructure, so mainly the roads and the traffic in the city. We do track that as well. And for example, we have an AI solution where from aerial footage we can inspect the quality of the pavements and the roads and make decisions where to fix something. And the last pillar is we work as a somewhat exotic quality assurance company where we try to make sure that all the services that the citizens of Vilnius are provided are top-notch and every requirement is being met. Now, what stands us apart from other, at least public service companies, is that in focusing on all of these three pillars, we focus very heavily and rely very heavily on data and on cutting-edge AI solutions. And we get our data from various data sources, from IoT devices, sensor data, telecommunications towers. I'm not even talking about some old databases and APIs. But the biggest data source that I personally work with is drone footage. And every day above, in Vilnius skies, above the citizens' heads, we are flying from 8 to 10 drones, and we complete from tens to hundreds of missions. So what is a mission? A mission for a drone is basically fly to a certain coordinate, film the area or take a picture of that area and send the image back home for us to analyze. And this is just a typical view of a drone image. So a typical image is about 8,000 to 6,000 pixels in dimension. So one can imagine that if we're having in the database tens of thousands of these images and videos as well, we can start, talking about big data, which is a bit of a, forgotten term in the age of ChatGPT. So I'd say we're dealing with big data. And I do realize that I'm standing on a stage called Industrial AI and Analytics, so please just bear with me for a couple of minutes and I'll tell you how our AI solutions really do move heavy machinery around. So as I mentioned, we are working as a somewhat quality assurance company. And in Stockholm as well and in Vilnius, you may encounter sites like these where, the waste areas or garbage bins are overflowing with waste. And the feedback that a company who should take care of this is getting mainly by angry citizen texts, by Facebook posts, by some videos, maybe sometimes through the press. So we just put our heads together and thought, how can we help them in improving the cleanliness of the city, right? So we thought about merging AI with drone footage, and maybe we thought that somehow whenever a drone flies over a waste area, maybe we can automatically well, detect whether a waste area is clean or not. And now, how do we structure any AI project that we do in ID Vilnius? It's, well, it's based on the data-centric AI approach. And now, if you would forget everything that I will be talking about today, please remember just this one thing, and you can, when you go back to your companies, please, you know, enforce this. So basically, AI can be dumbed down to an equation where an AI is basically code plus data. And up until, I don't know, 5 to 6 years ago, personally, I was witnessing that a lot of teams were focusing mainly on the code part and not on the data part. Everybody wanted to create some new algorithms, some, you know, fine-tune or create new hyperparameters for existing models. But this is all fine and good if you're a company with huge R&D budgets, because, well, most of the time, you won't create something, you know, much better than what comes from academia or those, you know, big corporations, and it's very hard to forecast when the project will be done, because, well, it takes some courage to go to the stakeholder and say that, well, our project can take from 2 weeks to half a year, and in the half a year we're even not that certain that this will be completed, right? So what we're focused on, and this is not my idea, I was very heavily influenced by Andrew Yang. We are focusing on the data part of the equation. So whenever we come up with a new, well, challenge or trying to figure out a new solution, we just spend a couple of days of finding the best open source tool for the problem at hand, and then we focus mainly on the data. And we, well, label the data. We try to make sure that the data quality is well, top-notch. And by iteratively, after some labeling sessions, we can, you know, train the model, see the accuracy metrics, and then start seeing and start predicting when will the AI be, well, is production ready, right? So it's much more easy to communicate with the stakeholders. And basically, what I was talking about in the previous slide can be summed up with this one beautiful image. So what we're asking from AI is to find the container areas. So a human just needs to find with his eyes and hands the area of interest in the image. So in this example, it's the container area. Just draw a rectangle box around it, and after a couple of thousand or even tens of thousands of these, we can start, you know, training the model. So yeah, I hope you can see it. It's in the middle, the red rectangle. And I know that especially on this stage, you are quite bored with seeing the graphs like this, so I just dumbed it down to the most essential parts. So basically, any computer vision project that we do in ID Vilnius, well, starts with the data and the annotators. So we try to identify what object to spot in the image. Then we give those images to the humans to label them. Then after, you know, a certain period of time, when we have enough images and enough labels, we give it to an open source ML algorithm. And a couple of presentations ago, I heard the term YOLO, you only look once model, so we use that as well. So it's quite cutting edge, very easy to use, and all that it asks from us is just a bunch of data. So we give it lots of data. Then when the very tasty AI cake bakes in the oven after a couple of days even, we put the model as an API in the clouds, and whenever a new image comes in, we can in real time basically get you know, the predictions. So what I will now show you, I can guarantee that you won't find it in any forum, in any GitHub project, and like nowhere in the internet, because this is completely custom built by ID Vilnius solution to identifying the waste areas from a drone footage. And yeah, now it's in these two videos, it's the same area. Just one is in the summertime, another is in the wintertime. So as you can see, the AI is starting to pick up where the container area is. And this is basically, you can see what the drone sees, right? This is the basically real-time. Yeah, this is a real-time video. Well, not from right now, of course, but this is how basically our AI models work during a drone flight. So why did I include two of these? Well, just to emphasize the difficulties of a project like this, because, well, Vilnius, as I'm sure Stockholm as well, has very distinct 4 seasons of the year. So initially, we trained the model only with images from summertime, and well, everything worked fine and dandy during the summer. But you know, when winter came, everything fell apart. So now we have a huge data set. Yeah, this is now the winter time is beginning. So okay, it stopped very soon. The winter video, but okay. So then you will just have to trust me that the winter one works very well as well. Yeah, so right now we have a data set covering all 4 seasons with thousands of images. But just to infer where the container area is not enough. We still need to answer the question of whether the area is tidy or not. So whenever we spot the container areas in the video or in the image, then additionally 3 models kick in. So once again, for every of these 3 models to create them, we follow the same data-centric approach, use the same model. Of course, the labels were different. And here you see the mishmash of the prediction. So we have a model to predict the waste types. So if there is an object around the waste areas, we label it as either paper, greenery, tires, or other waste. Then we try to identify whether the garbage bin or these big container lids are open or closed, because it's very it is very needed that those lids are closed, especially during snow times and rain times. And the last model is to predict the type of the container, whether it's the classical big container, we just label it as a waste container, whether it's a sandbox, because especially during winter times there are sand containers near the areas just to use on the pavements, and whether a container is a portable container or not. And basically, we relay this information that you see right here in the dashboard for the company who handles the waste to see. So now, instead of just driving around the city, they can just make a cup of coffee, open up a dashboard, and see that if a point is red, then probably something is bad in it. It can expand the image, see all of these predictions, and then make a decision. And here is just a very quick testimony from the client. So basically, they say that everything's fine. Their processes improved. So that's a very good feeling, because as I said, we were labeling the data for a year because we had to cover the 4 seasons, and now when everything is coming together, it's a brilliant feeling, right, for a machine learning engineer. And lastly, I want to say that not only the waste project is not the only one that we're doing in ID Vilnius, but one interesting project was during the snow time. We wanted to make sure that the company who is in charge of cleaning the snow from the pavements is doing a good job or not. So we have an AI to infer whether the pavements are cleaned or not. So this was completely made in-house as well. Once again, using the same data-centric approach that I want to put it in your heads. Then we have a very interesting AI solution to inspect the quality of the roofs, where basically a drone flies over a building and we can try to predict how many puddles or greenery there is on the roof. And based on that, we can try to evaluate the quality of the roof. And besides the computer vision projects, we try to forecast, for example, the population sizes in various districts of Vilnius, and yeah, many other solutions as well. So yeah, that was me. Thanks for listening, and